Welcome back. Let's go ahead with part 2 of the review. Here we're to factor a polynomial, and what you always want to do first is just stare at the polynomial and see if you see anything interesting about it. And what's interesting about this one is that it has a perfect square up front and a perfect square at the end. The other thing that's interesting is it has two variables. It has an x and a y term, so you're going to have to be careful about how to handle that, although it's no big deal. So let's rewrite this in terms of its perfect squares. Now remember, when you see perfect squares, you want to know if it fits the formula a squared plus or minus 2ab plus b squared. So let's see if it does. So we want A is going to be the 7x, and B is going to be the 2y, and so the question is, does negative 28xy equal 2 times A times B? So 2 times 7x times 2y should be 28xy. So we have 7 times 2 is 14. That's 14x. 14x times 2y is 28xy. So that means that this is a perfect square trinomial. So the formula for a perfect square trinomial is a squared, and we're going to use the minus 2ab plus b squared, which is the form of this trinomial, is going to be simply a minus b squared. So it's easy to factor once you decide first that it is a perfect square trinomial, and second that you know what a and b are. So the answer to this one is simply a minus b, 7x minus 2y squared. And then if you're not sure about that, you can FOIL it out and you'll see that it does equal what we started with. There is another way to do this. You can do this using grouping, but the problem is you're going to be dealing with very large numbers. Like in grouping, you would take 49 times 4, and then you would find two numbers that multiply to that and add to negative 28. And so as you can see, that can be very difficult to work. That's why this formula is so handy. When you see a cubed term, and then what you want to do is, if it isn't a sum or difference of two cubes, then you can think that it's either prime or there's something else going on. And in this one, there's something else going on. So you always want to ask yourself, is there a greatest common factor between these three terms? So first look at the coefficients, 18, 3, and 6. And you can pull a 3 out of there. So let's put a 3. And then let's look at the variables. We have m cubed, m squared, and m. You can pull out the variable with the lowest degree. And then n squared, and n cubed, you can pull out an n. So what do you have left? The way you tell what you have left is you divide everything by what you just pulled out. So you do that in all of the cases, here and here as well. And so for your first term, you have 18 divided by 3 is 6, m cubed divided by m is m squared, n divided by n is 1. In your next term, you have 3 divided by 3 is 1, m squared divided by m is just m, so we have m, and n squared divided by n is just n. And in your third term, 6 divided by 3 is 2, m divided by m is 1, so you have 2, and then n cubed divided by n is n squared. Now that we've factored the greatest common factor out, we ask ourselves, is this trinomial in here? It's not a difference of cubes or a difference of squares, and these are not perfect squares, and there's a coefficient here that is not 1. That means we have to use grouping. And grouping's a little different than what we would do with what we call reverse FOIL if the coefficient was 1. What you do is you take the coefficient in your first term and the coefficient in your third term and multiply them together. And that gives you negative 12. We won't worry about the m and n. And then in the middle term, your coefficient is 1, so you need to find two numbers that multiply to negative 12 and add to positive 1. So you need two numbers that only have one difference, and that's going to be 4 times 3, and your 4 needs to be positive and your 3 needs to be negative so that they add to a positive number, and that gives you 1. Okay, now the next step is the extra step that you do in grouping that you don't do in reverse FOIL. Okay, let's first bring down our 3mn. We don't want to forget that. And now we're going to use brackets. So we're going to write 6m squared. So we just bring down the first and third term, but we break up the second term, and we're going to put minus all first to save us from the trouble that can come from dealing with a negative in the middle. Then we have plus 4mn, and you can see that the minus 3mn plus 4mn equals this mn. So that's why we can do this. And then we have bring down the minus 2n squared. Okay, so what we do now is we group. If this were a negative, we would need to change subtraction to addition, but since it's a positive, we can go ahead and just group these two terms and these two terms. And so our next step is to factor common factors out of both of those binomials we just grouped. So in the first case, there's a 3m that we can pull out. So here's your 3m. And when you pull out a 3m, you're going to be left with something that you know what it is by dividing. So 6 divided by 3 is 2. So we're going to have 2, and m squared divided by m is m. And in the second term, we're going to have the 3m. This should be an m. Here, the 3m divided by 3m give you 1, so you're left with just n here. And in the second group, you still need that plus. You're going to factor out 2n. So when we factor out 2n, we're going to be left with 2m minus n, because we divide this by 2n also. So as you can see, this binomial and this binomial are exactly the same. So our next step is to factor out that binomial from both of the factors, and what we're left with is 3m plus 2n, and that's the answer. Okay, here we have two terms, so unless it's a difference of squares or a difference of cubes or sum of cubes, we can call it prime. But in this case, it is actually a difference of squares. So let's go write that down in terms of squares. So we have 2w, all of that squared minus 3 squared equals 0. Now notice here, we're not just factoring, we're solving an equation. So we're going to be doing an extra step. But first of all, the formula for the difference of squares is a squared minus b squared, and this is very important. We'll be using this throughout the semester, is a plus b times a minus b. And so 2w is your a and 3 is your b. So we have 2w plus 3 times 2w minus 3 equals 0. So now we factored it, but we're not done. We have to use the zero factor property, which says that for this whole expression to equal 0, either this or both have to be 0. So in order to solve, we set each of those binomials to 0, and then we solve for w. Okay, so we subtract 3, and then we divide by 2, and we get w over here is negative 3/2. So if we plug negative 3/2 into one of these binomials, it would force the expression to be 0. On the other side, we add 3 to both sides and divide by 2, and we get w equals positive 3/2. So we have two solutions, and if you have a squared degree of a binomial or trinomial, you're going to have two solutions. If you have a cubed degree, you're going to have 3 solutions. So let's go ahead and write our solution out using brackets. We don't use parentheses, and it doesn't matter what order you write them in, and that's the solution. When you're taking your tests, you have to be very careful to read the instructions. We've been doing a lot of factoring, and we're going to be doing a lot of solving, so you need to know if it's going to be to solve or to factor. The other clue is if it has an equal sign, you're going to solve an equation. If it doesn't have an equal sign, you're just going to factor an expression. So let's go ahead and work on this. When we look at this equation, you see that nothing equals 0, and we want our equation to be something on the left equals 0 on the right. We have our 6x squared term on the left. We want, all right, that's going to be our leading term because it has the highest degree. So we want that to be positive. Our leading term should be positive. So what we're going to do is subtract 5x and subtract 4 from both sides, and that will leave 0 on the right. So as you can see, minus 4 minus 5x produces 0 on the right. So we also subtract minus 4 minus 5x here. And what we're left with on the left is 6x squared, and we'll put it in descending power order. So we have all of that equal to 0. So now we're going to do factoring, but that's not all we're going to do. This isn't a binomial, so we ask, is it a perfect square trinomial? And the last term is a perfect square, but the first term is not. So then we ask, is the first lead term have a coefficient of 1? And it does not. So that means we're going to use grouping. And in grouping, we start with a chart just like we do with reverse FOIL. But in our chart, we multiply 6 times negative 4 to get negative 24. And our second entry is negative 5. We need two numbers to add together to give us negative 24. To multiply to give us negative 24 and add to give us negative 5. Now, to get a negative number from two terms, one has to be positive and one has to be negative. And to add those terms together so that you get a negative number, the larger one has to be negative. So let's try negative 6 and positive 4, and they add to negative 2, so that won't work. So let's try negative 8 and positive 3, and they add to negative 5, and that does work. So we rewrite our expression on the left, but here's a common mistake that people make. They come over to the left and they write 6x minus 8 times x plus 3, which is kind of like what we do when we're doing reverse FOIL. And that is wrong. You will get the wrong answer. If you FOIL this, you will see that it does not give you what we started with. So instead of doing that, all we're going to do is bring our first term down and our last term down, and then we're going to break up our middle term using the numbers we found. So let's do that. We have 6x squared, we just bring that down, and then we break up the middle term. Start with your negative, and then put your positive second, and then bring down the last term. So since we started with our negative and then did the positive second, we have a plus sign in the middle, which is what we want, so we can go ahead and group. And this is why it's called grouping. Now we find the common factor of each one, and in the first one we have 2x as our common factor, leaving 3x minus 4. And in our second one, 1 is what we put in front because 3x minus 4 doesn't have any other common factor. So then we just write 3x minus 4. And now we see that this binomial and this binomial are the same and can be pulled out front. So we treat that as our new greatest common factor, and we're left with 2x plus 1. Okay, so we've factored it, but we haven't finished the problem because all of this is equal to 0, like up there. So in order for this times this to equal 0, according to the zero factor property, either this equals 0 or this equals 0, or both are the case. So what we do to solve this, and when we solve, we're finding a value for x that makes the equation true. And this is how we do it. We set each of those binomials equal to 0 and solve for x. So we add 4 to the left binomial on each side, and then we divide by 3, and we get x is equal to 4/3. On the right, we subtract 1 from both sides and divide by 2, and we get x equals negative 1/2. So again, we have a quadratic expression that we started with where the degree was 2. We expect 2 solutions, and that's what we have. And here's how you write them. And if you plug either 4/3 in or negative 1/2 in for x, you will find that one of these terms is going to equal 0, and that will give you 0 as a result. If you plug it into your original equation, same thing, you'll get 0. That is the end of part 2 of the review, so now go ahead and go on to part 3.